Alright, and so on Desmos, I just wanted to show you guys this wonderful calculator if you haven't already. You can graph all kinds of amazing stuff here. I'm going to zoom out a little bit so you can see what this graph is doing as I work with it. Okay, so I mean you can graph a whole bunch of stuff and just work with it and just be able to find the inverse functions, because the inverse functions you're going to find they, let me see, do an inverse function in my head real fast. Okay, when you graph them, so for example, these two are inverses of each other, they will appear to be like, they kind of intersect and stuff, and like, oh, that's great and everything. But guess what? If I graph the y equals x line right over the top of them and you tilt your head 45 degrees to the right, you can actually see some very nice symmetry with the y equals x line. Okay? Alright, so that being said, that is a graphical way to actually find the actual, I guess you could delete this one, you could delete this one, keep that line, and you always want to keep y equals x, because in inverse functionality you are switching the y and x values to see if it does have that kind of amazing symmetry. So like y equals x to the third is going to be the inverse of y equals x to the 1/3. Okay, and as you can see, if I zoom in really close, it's going to look really gorgeous. I mean, look at that. That looks like a really nice vase or something. So it's kind of cool how it works that way. All right, and let's go back to, where was I? Oh, there I am. Okay. All right. Also talking about some more functions. Just setting these ones up, just being able to type into Desmos, you do have to use square root, and it will give you the symbol for that. And if you wanted to do a rational function, you do have to do the little caret, and it will bring it up. All right, even and odd functions. Even functions, graphically, they have y-axis symmetry. Algebraically, if you plug in a negative x, you get the same exact function. F of negative x equals f of x. That's the notation right there. Odd functions, graphically, they have symmetry with respect to the origin. In other words, they can be rotated 180 degrees. So that's the meaning behind it. Okay, now algebraically, if you plug in negative x, you get the exact opposite function. So in other words, this means I plug in negative x, this means I get the exact opposite function. Okay, also remember your domain goes from left to right, your range goes up and down. You should be fine with graphs. You know, if we've made it to this point, we should be pretty good. All right, now talking piecewise functions and composite functions. Real fast, I like to use Fog and Goff, and it just basically you take g of x and you plug in an f of x, and for Goff you do f of x and you plug it into g of x. Now, one of the earliest examples of piecewise function that you guys saw was an absolute value function. It actually had a bend right here, and we'll talk more about that in calculus as being the that is just, that's called it's not being very continuous and stuff. And you can actually make your own piecewise functions on here. So y equals negative 2x, yeah, let's just leave it at negative 2x, and y equals x squared. Okay, so let's do something like that. Alright, and now the intervals is what you want to do. So you want to use the little curly bracket. Okay, and you want to go, okay, I want to graph everything less than negative 1 for x, and there you go. Alright, now if you bring your arrow over here and leave it on there, you're going to see a hole, and that's because I have a less than sign. If I had an equal sign right next to it, if I go equals, okay, and I'm using the less than and the equal sign on my keyboard, you can see it actually goes to it, it defines it. And you can also do this one right here. So, oh, I need the braces, the curly braces, and we got x is greater than negative 1. Okay, and as you can see, I have a piecewise function right here. Okay, and it lines up perfectly because it is a function, but it's not a continuous function, which is something we will talk more and more about. Basically, functions in calculus, we like them to be nice and smooth curved, where we don't have to pick up our pencil if we were to actually draw and reproduce this. Okay. All right. Exponential functions. Exponential functions, some key things to know: they always intercept the y-axis at 1, and it increases exponentially. The inverse of it would be y log base 2 of x. Those would be the inverses. And parametric equations, you just take your original equation and you'd split it into two parts which have a t in the values. Okay. All right. Exponential growth and decay. If we talked about that real fast, let's talk about it. AB to the RT. Okay, let's say that. Okay. All right, so this b number is the number, this is the base of the exponential. Okay, if b is less than 1, if it's between 0 and 1, you are doing exponential decay. If it is greater than 1, you are doing exponential growth. If it is 1, you're kind of just staying where you're at, and it's just a straight line. Okay, and you can check it out on Desmos and just work with it, but you know, that's the stuff right there. If I go back to Desmos and I show you the trig, no, I won't show you the trig right now. I'll show you that a little bit later. Okay. All right. So, but anyways, check out Desmos. There's a lot of great uses in here. It is a wonderful thing that just it helps you graph stuff. It helps you see stuff a lot easier. Okay. All right, you guys. That is it for today. That is it for your introduction to calculus. Welcome, and I will see you again.